In this example, we're going to use L'Hopital's rule to calculate a limit. All right, the limit is the limit as x goes to 0 from the right of the function e to the x minus 1 over x squared. All right, so this is the limit as x goes to a number. So the first thing that we're going to do is plug that in and see what we get. And so we get e to the 0 minus 1 over 0 squared. On top, we wind up with, because e to the 0 is 1, we wind up with 0 over 0 here. So we can use L'Hopital's rule. And so what we would do is to take the derivative of the top. The derivative of e to the x is e to the x, and then minus the derivative of 1 is 0. So on top, we'll just have e to the x. On the bottom, we will have x squared, the derivative of x squared, and that is 2x right here. All right, so now we want to take a look at this limit and see what it comes out to be. It's the limit as x goes to 0, and so we're going to plug in the 0. When we do that, on top we get a 1, and on the bottom we get a 0. Okay, so that is a non-zero number over 0. That's going to tell us that the limit is going to be either infinity, negative infinity, or it does not exist. So the question is, well, how do we figure out which one it is? Okay. Well, we're going to use exactly the same technique that we did in section 1.4 for infinite limits. All right, so do exactly the same thing. What we're going to do is analyze the bottom part of the function. We know, right, that the top part is equal to 1, right? And so that's a positive number, and we know that. And we know that the bottom is going to 0. So our question really is it going to 0 through the positives, through the negatives, or does it kind of waffle back and forth between the positives and negatives? And so to figure that out, what we're going to do is just analyze this bottom part exactly like we did in section 1.4. So we would take the bottom part and we would set it greater than 0 and solve that equation out. And when we do that, we're going to figure out everything basically there is to know about what's going on with the bottom part. And in this case, the inequality that we get is an extremely easy inequality to solve. We didn't really have to do anything that we did in section 1.4 in some of the more difficult problems. We just want to solve this inequality, so we would just divide both sides by 2, and we would get that x is greater than 0, which makes sense, right? If you are greater than 0, then you're positive. If you plug a positive number in for x into 2x, well, the result's going to be positive. And if you plug a negative number in for x into 2x, well, you're going to get a negative number, right? And so the situation was actually more complicated in the examples that we did from lesson 1.4. Okay. So what does that tell us about the limit? Well, it tells us we had the limit as x goes to 0 from the right of e to the x over 2x, right? And 1 we knew was positive, right? There's no question about that. And the bottom part was going to 0 from the right, right? And so through the positive numbers, what that means, right, is that the bottom part, the bottom number is going to be positive, right? So I will have a positive over a positive as I go to 0 from the right side, right? I'm only looking at numbers that are bigger than 0. I'm getting closer and closer to 0. So the bottom part is going to be positive. So that tells us that the answer has to be positive infinity for this function right here, e to the x over 2x. And so therefore, by L'Hopital's rule, the original function, which was, or the original limit, the limit as x goes to 0 from the right of e to the x minus 1 over x squared, also has to be infinity.